Hello everyone, this is Vidya and I'm here to talk about e-waste recycling using nanotech benefication. I'm here to present you with this PDF and give you an introduction to this topic. I would like to continue with presenting the PDF. So here we have a PDF and before we go into this matter, I would like to share some other topics which form a basic for this whole topic. First, coming to electronic waste or e-waste. Uh, e-waste is nothing but the electronics that we use in either practical or a personal life or in business life. All those kind of electronics produce some kind of waste after the extent of their usefulness is over. So this is nothing but your e-waste. And when we go to the sources of e-waste, they can be your DVD players, laptops, TVs, etc. And e-waste generation across the world is as much as 50 tons of electronic waste a year, weighing more than all the commercial airliners ever made. Only 20% of this is formally recycled. All the others is just wasted. And the amount of cost uh, problems, efficiency problems, and also the health problems that we face because of this is a lot. Now, let us go to the next point, which is harmful effects of e-waste. All these topics is something I would like to just sum up before I go to the main topic. Harmful effects of e-waste, especially on human body, include reproductive issues, developmental problems, damage to immune system, and kidney damage, and skin ailments or your skin problems, your DNA damage, and muscle weaknesses, either in short term or in long term. And then we move to the recycling techniques. We have many recycling techniques for your e-waste recycling. Initially, let me continue with those which are already present and which are now used. These are pyrolysis method. Your pyrolysis method is a chemical recycling technique extensively used for recycling synthetic polymers, including polymers that are mixed with glass fibers. So pyrolysis of such polymers give gases, oils, and chars. These products can be further used as chemical feedstock or fuels. So this is your pyrolysis method. Coming to your next method, it can be hydrometallurgic method. This process is majorly used for profitable recycling and metallic fraction. In this method, metal contents are dissolved into leaching solutions, such as strong acids and alkalis. This is followed by electrorefining of desired metals. The technique is considered to be more flexible and energy saving, hence it is cost effective. And then we have your mechanical recycling, classification method. The separation of PCBs by dissolving bromine epoxy resin using organic solvents. This is the DMSO method. I would not like to go deep into these topics because this study of the whole thing is majorly on cryo milling and cryo grinding and an experiment. And you also have your biometallurgical separation method, magnetic separation method, etc. Now let us go into our main topic, which is cryomilling. Cryomilling, the word cryogenics originates from a Greek word which means creation or production by means of cold. So you can see in the slide, cryogenic process is used to embrittle and grind materials to achieve consistent particle size for a wide range of products. So basically what is involved in this process is they grind the materials or the electronic materials that they grind to form a range of particle size, to get a range of particle sizes. It can also be, this also has a unique capability for recycling difficult and to the materials which are difficult and to separate. This is achieved during this cryogenic process. Solid materials are ground or pulverized by way of hammer mills, granulators, or many other kind of equipments that are used in this process. A smaller particle size is usually needed to enhance the further processing of the solid, as in mixing with other materials. A finer particle also helps in melting the rubber and plastics for molding. However, many materials are either very soft or very tough at room temperatures. By cooling to cryogenic temperatures with liquid nitrogen, these may be embrittled and easily fractured into small particles. Advanced ceramics are widely used engineering materials because of their superior physical and mechanical properties such as hot hardness, wear resistance, and strength. The present study right now reveals a significant improvement in the ceramics. So basically, the advanced ceramics, these are widely used as engineering materials for this process because of their properties that I have just mentioned. So going further, these are the components that are used. So this is the ceramic process that I have mentioned, this usage of ceramics that I've mentioned. And also they use the SEM method, or scanning electron microscopy method, to observe the damage length uh, for this ceramic process. And coming further, we go into cryogenic grinding. So what is cryogenic grinding? It is also known as freezer milling or freezer grinding or cryo milling, which is an act of cooling or chilling a material and then reducing it into small particle size. Solid materials are ground or pulverized by way of hammer mills, attrition mills, granulators, and other equipment, which we already discussed. So your cryogenic grinding is a process that is involved with the cryomilling technique. So this is how you achieve cryomilling. So we use coolants over here. And why are these coolants used? The extremely low temperatures are produced by using substances called cryogens, such as the liquid nitrogen and liquid helium. All these cryogenic liquids are gases at normal temperatures and pressures. So these gases must be cooled below room temperature to liquefy them. So in order to have this, we use coolants. And these kind of coolants, as mentioned, decrease the temperature to the certain level so that this process can be carried out. And later, moving on to, yeah, this is the same process that I've talked about, cryogenic grinding process. So basically we have pulverization, that is the making the materials into small particle sizes or grinding them into small particle sizes, and then separation of these composites or separation of different particle sizes. So I would like to go further to the working of cryogenic grinder. So we have it over here. I would like to show you the diagram that is involved over here. Yes. So in this working, material is to be ground, is cleaned manually and fed into a hopper. From the exit of the hopper, the material enters into a vibratory feeder, which is positioned with a small inclination towards the entry of helical screw conveyor. It has the ability to control the feed rate. So basically, this is a hopper at the leftmost top side, and then we have this over here. You're giving feed into this hopper, and there is a vibratory feeder, and this enters into that. This feed enters into that. Liquid nitrogen from the storage container is sprayed into the skewer conveyor. The time of stay of material is the conveyor can be maintained by varying the speed of the drive. Conveyor, that is the conveyor drive basically. You can adjust the settings of it. The sensors monitors material temperature in the conveyor is also monitored. When the mill is running, the materials get crushed between the studs and comes out as an optional sieve as a ground product. To the bottom of the mill, a collecting bin is housed where the ground product gets collected. The vaporized nitrogen from the mill is sucked by a centrifugal blower, and through the filter assembly is feedback to the mill, and the cyclic process is continued. So basically you keep on adding this feed which goes into this machine, or this conveyor, it gets crushed, and the extract or the sieve that you're getting from it is collected at this place. So this is the base diagram. Now I would like to continue with the advantages and disadvantages of cryogenic grinding. First, coming to the advantages, it decreases the wear of grinding equipment, and separation of composite materials within the mill is possible. More uniform particle distribution is observed. Lower energy consumption takes place in this process, and also minimal loss of any kind of volatile components is observed. Coming to the disadvantages, economic consideration should be solved. So the economic cost or efficiency and all are still to be solved. Filtering of screw conveyor is difficult. Maintenance cost is above the range, which is very high, and hence concluding that the operational cost is high. Now coming to a major topic, which is the recycling via cryogenic uh, and nanoparticle benefication, which is a good process used in nanotechnology and which is being researched. I would like to say that this process has this cryomilling and cryo grinding techniques. So basically, uh, experiment which was done consists of this PCB which is taken and is grinded, and it is observed that nano-sized powders of single phase are obtained from this grinding process. So here an optical mouse was used in this experiment as an e-waste for this experiment. An optical mouse was used. The optical mouse was dismantled from PCB board and was removed from it. The two PCBs were milled for 30 minutes using a specifically designed cryo mill at certain temperature, and then you have this kind of different particles analysis and observations that are performed, and later there are many agents added to that solution, added to that, and solution was made. The solution was stirred and allowed to cool down for a few minutes, and then a hardener solution was also added to this. This hardener is used to cure the resin. The obtained mixtures were poured into cylinder-shaped plastic molds having dimensions of which were allowed to cure at room temperature for 24 hours, and followed by a vacuum desiccation for 24 hours. So basically the whole solution that we said, it is allowed to cool down. After that, it is put into molds and it was allowed to cool down at room temperature for 24 hours, and then it was given a vacuum desiccation for 24 hours, for another 24 hours. So using many techniques like UTM, which is the universal testing machine, the compression strength of composites were determined. Coming to our next part, here we have used these nanoparticles to actually, we have used these e-waste to actually mill them and get a nano-sized powders. And from this nano-sized powders, we have achieved to make a product out of it without actually getting it to waste. And also let me say you that these PCBs which are used, not essentially PCBs, the experiment was on PCBs, but any kind of electronic waste can be used and tested for this experiment. And after the whole process taking place, they have concluded that there are two processes, which is the recycling via nanotech benefication or separation into individual classes, and separation into polymer composites, which can be directly used as mechanical structures. So coming back to this, the whole process is just defined in a way where we take an electronic waste, and this electronic waste is made into smaller particles using cryogenic mills, by using the cryogenic grinding system. And then these smaller particles that we obtain in nano-sized powders, these have different wide range of wide spectrum of sizes of nanoparticles in this, which can be further divided and separated. And after that, it is harder to separate, even though you can recycle all of them, make them into molds, and use them for further recycling. And hence, your e-waste is not going into some kind of garbage polluting the environment. It is actually getting recycled to another product. So we have this rule saying recycle, reuse, and recycle and reuse, and this is one of the process that can state that the waste can be reduced to a very very much of extent. And coming to this part, we have seen in statistics that 20% of the e-waste totally produced is only which is being recycled. What about the rest? It just goes into the environment, harms it. These e-wastes, why is e-waste actually harmful is because of the chemicals that are inside it. The lead, mercury, other chemicals used inside it, which is proved to be very harmful for human beings. Hence, this process is one such thing which is an experimentation, and its complete utilization can actually bring a lot of advantages to our society in terms of waste management. So, thank you everyone. This was my presentation over uh, e-waste recycling using nanotech benefication.